So welcome to this fourth and final part of the series on inequalities. So this time we'll be dealing with absolute value inequalities. Let's go on with our first example. So in here, like how it usually goes, we isolate the problematic one on one side. So that means that we must move 8 to the other side, or technically that is subtracting 8 both sides. That will give us the following. So we have your absolute value of 3 plus 2x less than negative 1. So in here, before we proceed, recall that given an absolute value, we know that its output value will always be greater than or equal to 0. So given that, is it possible that it is less than negative 1? The answer to that is impossible, since it's impossible that for any value of x out here that we plug in, it's impossible that we get a value, output value out here that would be less than negative 1, which means that the answer for this problem is no solution. So let me put here a y so that you can recall the definition of absolute value that would yield the answer of no solution out here. So that's basically the answer for this problem. Let's move on to the second item. So for the second item, we have the absolute value of 3x minus 1 plus 2 greater than 2. So for this next one, like how we did in the first, we first isolate this to one side, meaning we move the 2 out here to the other side. Or that is, let us subtract 2 both sides. So subtracting 2 both sides would yield the following. And then from here, like earlier, recall that absolute value out here means that the value will be greater than or equal to 0. Or that is, any value that we plug in out here would yield the value that is greater than 0 or equal to 0. Basically, for any value, we know that we'll get a greater than 0 except with one value. And that one value is the time when this one will be equal to 0. So writing that one down, we know here that the solution would be all real numbers except for a certain value. So that certain value will be determined by the time that this thing is equal to 0. So let's solve for that one. So in here, we have 3x minus 1 equal to 0. Let's add 1 both sides. So we'll have here 3x equal to 1. And then dividing 3 both sides so that this one will cancel out will leave us with x equal to 1/3. So basically, the value that would make this thing 0 is x equal to 1/3. So let me put an exclamation point out here so that you'll remember the scratch that we did out there. So this makes sense because, again, any value that you plug in out here will be greater than or equal to 0. So we just omit the case that it is equal to 0 or the time when x is equal to 1/3. So this one out here is basically the answer for this problem. So now that the basic cases are out of the way, let us proceed with the more exciting items. So we have this third one. So for this third item, we have absolute value of x minus 2 greater than or equal to 3. Again, the first step is to isolate the absolute value to one side, but fortunately for us, it is already isolated here. So we proceed with the trick in absolute value. So let me write it down here. So recall in absolute values that given an absolute value of a, wherein a can be any expression, greater than b, it's not necessarily just greater than, it can be greater than or equal to. This thing is equivalent, so when I use IE, that's basically is equivalent to a greater than b or a less than negative b. If you're not convinced with that one, just take, let's say, b to be equal to 1. So if we have 1 out here and 1 out here, any values that we plug in out here, let's say 2 would satisfy the given original inequality. If you plug in out here negative 2, take the absolute value, it will satisfy this. Applying that to our problem, we'll have the following out here. We have split this absolute value into 2 separate inequalities, x minus 2 greater than or equal to 3 and x minus 2 less than or equal to negative 3. But take note that the or out here represents that these two things happen separately. So we deal with them separately. So dealing with this first one, what we do is we add 2 both sides so that x will be isolated. For this next one, we actually do the same thing. So we add 2 both sides to obtain the following. And then from here, are we done? Yeah, basically this is the answer in the usual notation. Just take note that or out here represents basically union, since these two things happens separately. If you want an interval notation, we have the following. X to be in the interval negative infinity to negative 1 with 1 included. So this one represents this one out here. Union 5 to positive infinity with 5 included to represent this one. This thing out here is the answer for the problem. Good, so now let us go on with the last item. For this last item, we have 3 times the absolute value of 8 minus x plus 2 less than 7 minus 2 times the absolute value of x minus 8. For this one, it's kinda scary because we have like 2 complicated expression, but the same trick applies. We first isolate the absolute value to one side. And if you want, we can actually first write this out here into a single variable just to simplify things out. So let us define a to be equal to the absolute value of x minus 8. So you might be wondering, how about the absolute value of 8 minus x out here? Do we still need to define a variable out there? Actually, we don't need to. All you need to do is to take note that this thing out here is equal to negative x minus 8, then you take the absolute value of this. And just recall that when you have a negative of something in the absolute value, you can actually omit the negative part since it has no bearing in the value of this thing out here. So essentially, what I mean by that is these two things are just the same. So we treat them both as 8. So we'll have here 3a plus 2 less than 7 minus 2a. From here, all we need to do, like how we deal with linear inequalities, we isolate this one with a variable on one side. To do that one, we will move this negative 2a to the other side, or technically, that is, we'll be adding 2a both sides. We'll obtain here 5a, and then next, we will be moving 2 out here to the right side. So that's technically subtracting 2 both sides. So that will leave us with just 5, 7 minus 2. From here, dividing 5 both sides, we will obtain a less than 1, or we can return actually back this one so that we'll be able to align our solution back to the original given problem. So recall that earlier when we encounter this thing, what we do is we split them up, but this time we have the opposite direction, less than. So basically this looks like absolute value of a less than b, disregarding the connection between this a and this, so it has nothing to do with that. So for this case, we do different trick. So before that one, just for clarity, what we did here is we returned a back to the original form. So this time, for this case, what we'll be doing out here is first recall that if we have an absolute value of the form this less than a certain value b, then this is the same as a between negative b and b. Again, this is not limited to just less than. You can have your less than or equal to. We'll just replace this with less than or equal to. If you want to try this one, let's say b is 1, then this one will be from negative 1 to 1. And this makes sense since any value in between negative 1 to 1 will satisfy this one. If you go beyond that, let's say 2, then absolute value of 2 is not less than 1. If you go beyond that on the negative side, let's say this one is negative 2, that becomes 2 again since we have absolute value, and that won't be less than 1. So here we will obtain the following: x minus 8 sandwiched between negative 1 and 1. And then here, dealing with just a linear inequality that is sandwiched by something, some values, what we do is that if possible, we do things simultaneously. By that I mean, if our goal is to isolate x out here, we simply add 8 both sides in all parts of this inequality. So adding 8 out here will give us 8 minus 1 is 7, and then in the middle we have x, and then on the right side we have 8 plus 1, or that is 9. Actually, we can stop out here since this one is already the answer for the problem. But if you want, in interval notation, we can write this one as x to be in the interval 7 to 9. And this one is essentially the answer for the given problem. Good, so that's basically it. That ends the series on inequalities. So again, going back to where we started. So we first dealt with linear inequalities. Then we went over higher degree inequalities. And then we have also encountered rational inequalities, wherein we dealt with plenty of table of values. And then for this time, we had absolute value inequalities. So take note that for this one, there could be problems that involves a mix of everything, like absolute value involving rational, or higher degree involving absolute value. But we didn't deal with that one, just to simplify things. Just one thing to take note of in absolute value, aside from these basic cases, focusing on this 3 and 4, if you encounter a case wherein you have absolute value of a greater than something, expect that the answer would be this one with the union, because what we do here is we split. On the other hand, if you encounter a problem that has absolute value less than something, expect that your answer will be an interval bounded, since on the solution we did it of this form. That ends the series on inequalities. Before you go, please check the Google form link in the description and the comment section down below to help me provide better math content catered for you, like specific topics, specific format, specific problems that you want to solve. So that's it. Have a nice day.